My name is Dr. Peter Marshall and I'm a research methodologist. My flagship book on the subject is used in universities all over the world and published in several languages. In the previous module in this series we looked at how to choose the right questions to ask. In this module you'll be introduced to understanding the nature of theories. In the scientific sense, a theory is two or more interrelated hypotheses that have been supported by evidence. This is different from the more commonly used meanings of the term to refer to the written work aspect for manual skill courses in a training college or one of Inspector Morse's hunches. A theory is also different from a law, for a theory explains or can predict something in a proportion of cases, but a law explains something in every case. Many laws have been discovered to explain phenomena in the physical sciences, but they're not common in the social sciences. An example of a law in the social sciences is the law of diminishing returns. This tells us that increasing applications of a factor of production, for example land, labour or capital, in an enterprise, will provide increasing returns only up to a point. After this, the reverse will begin to happen unless the other factors are increased to bring things back into balance. Theories can be categorized as strong or weak. Strong theories may be used for prediction. Weak theories are only sufficient for explanation. The strongest theories will be expressed in quantitative terms rather than qualitative terms. All scientists work within paradigms. Paradigms are particular ways of thinking about their subject matter, which they share with others of like mind. They include assumptions, conceptualizations, values, attitudes, orientations and beliefs. Different paradigms have their own preferred methods and theories. Psychologists who have grown up, so to speak, in what is known as the behaviorist paradigm would not consider it necessary to understand a patient's experience of a neurotic illness. They would instead focus on the behavior. Appropriate therapy would be by means of behavior modification techniques. But in contrast, psychoanalysts would want to explore the patient's history to find the cause. They would expect to find it in some repressed conflict, and they would seek to cure the condition by bringing this into the patient's conscious awareness. Paradigms have advantages and disadvantages. An advantage is that they prevent scientists wasting time on problems that they're not best equipped to solve. In this way, they facilitate the benefits of specialization. A disadvantage, though, is that they blinker researchers to other valid ways of looking at the issues. The development of scientific knowledge can progress by focusing initially on facts or theories. These methods are referred to as induction and deduction, respectively. When researchers first begin to open up any new line of inquiry, there will be no useful theories available from which to deduce propositions for testing. Knowledge has to begin with collecting facts and then trying to find some order in them. This is known as induction. It would be naive to say that no theory at all is present at this stage. As human beings, we could not make any sense of anything without theory, however crude or even erroneous it may be. What is meant by lack of theory here is lack of scientific theory. Deduction is the technique by which knowledge develops in more mature fields of inquiry. It involves a sort of logical leap, going a stage further than the theory provides. Data is then collected to test it. If you're interested in doing research in a particular field, the way to start is to familiarize yourself with the general knowledge in that area. Collect everything you can from any source you can to build a file. Select a more precise sub-area that you find most interesting and study that area in great depth. Analyze your notes to impose an order that is meaningful to you. Physical scientists study real tangible things, atoms, molecules, planetary systems and so on. But social scientists study something much more abstract. Behavior, human ability, relationships between people and things like this. These things are not real in the physical sense, they are intangible, existing only in the mind. These are concepts. Some concepts are of a quantifiable nature, and others are not. IQ, for example, is a concept that refers to the level of a person's educational potential, and it's easily measurable. The concept of social class, on the other hand, is not. We cannot impute an exact measurement of the social distance between professional, managerial, unskilled white-collar, skilled manual, and unskilled manual workers. A model is a conceptualization of the way two or more concepts relate to each other. An explanatory model provides an explanation of the mechanisms that underlie such relationships. Models can be expressed verbally or diagrammatically. If they're expressed diagrammatically, there are conventions as to how they should be drawn. For example, concepts are usually represented as circles, and lines of influence are represented by double lines, single lines, or broken lines, depending on whether the influence is strong, moderate, or weak. Models are not always this complex. Sometimes a model may simply amount to a statement that two concepts are linearly related. This is known as a linear model and may be expressed as a graph. The relationship may not always be linear, of course. Thomas Malthus's model of population growth provided that levels of food resources increase arithmetically while population levels increase geometrically. Consequently, population levels would always outstrip food resource levels unless birth control or natural disasters checked the growth of population levels. When scientists wish to find out whether two things are related, they formulate a statement that they are. This is called a hypothesis. It's conventional for scientists to state two hypotheses: the target hypothesis, which they conventionally label H1, and what is called a null hypothesis, which they label H0. The null hypothesis simply states that the expected relationship will not be found. There's a good reason for this. Science can never prove things, it can only disprove them. If evidence supports a proposition, it's only the best evidence so far. Other evidence may be uncovered in the future which will tell quite a different story. So scientists set out to do what they are able to do, disprove something. The nearest they can expect to get to proving their target hypothesis is to disprove its null hypothesis. That is, the one which says that the relationship they suspect exists does not. A theoretical construct is a statement supported by evidence that two concepts are related in some way. Do not confuse this with a theory. That requires two or more interrelated constructs. A variable is a concept which can differ in its essence. The content of some variables tends to differ in measurable degrees, so we call them quantitative variables. Age is one example. Scales are ways in which concepts can differ. 4 types of scale used in scientific inquiry are nominal, ordinal, interval, and ratio. If a variable is measurable only on a nominal scale, it means it is completely non-quantitative. An example of this kind of scalar property of a variable is religion. A person's religion can fall into any of the categories of Catholic, Protestant, Muslim, Jew, etc. It would be unscientific to attempt to rank these in any order of importance or award them any quantified values. If a variable has ordinal scalar properties, it means that data can be ranked, although no precise calibration can be applied. That is, the difference between the ranks cannot be quantified. Differences in people's power and authority, as represented on a company structure chart, take this form. If a variable has interval scalar properties, it means the difference between the rankings can be quantified, but there is no absolute 0 point. IQ is one such example. And finally, if a variable is said to have ratio scalar properties, then not only are the calibrations between the rankings precisely quantifiable, but the scale also has an absolute 0 point. Temperature is one such variable. The language used in theory construction should be precise and unambiguous. All concepts and the relationships between them should be clearly defined. Although this is not always feasible, mathematical language, such as algebraic equations, is preferable. Scientific theories seek to explain or predict things. For a theory to be able to predict something adequately, it needs to be much stronger in its explanatory power than if it is to be used merely for explaining something that has already happened. Statistical associations underlying such theories need to be reasonably high. Correlations below 0.7 are therefore not very useful for predictive purposes in the social sciences. The reason theories need to be stronger for prediction purposes is this. If a theory fails to account satisfactorily for something which has happened, investigations can be made to explain why the explanation did not fit the facts tidily, in order to supplement the explanation. Where prediction is concerned, however, it cannot be known in advance whether or to what degree the theory will fit the facts when the predicted event actually occurs. Before I summarise, I will just share with you some questions people have asked me about this topic. Students often ask, how can there be more than one theory about something? Surely they can't all be right. Well, as pointed out earlier, theories are different from laws. Laws explain things in every case. Theories explain things only in a proportion of cases. There are a number of reasons why different theories can coexist. Firstly, they may focus on different levels of analysis. For instance, observational learning from exposure to television violence may explain aggression at a social psychological level, but it does not explain it at a psychobiological level. In the latter case, we need to explain it in terms of physiological structures and neurochemicals. Secondly, the reason different theories may be required to explain different cases of the same thing may be that there is a missing link or links in the knowledge. Someday this may be discovered and the two or more theories reconciled as one. Thirdly, of course, some theories may simply be wrong. They may simply be erroneous explanations which by chance appear to fit the facts. Another question often asked is why there is so much jargon in scientific writing. Is it to baffle us with science? Well, jargon should be kept to a minimum, but sometimes it's necessary in scientific writing because precise definition is important. The trouble is that many specialized terms are used in different ways. Researchers should always ask themselves what this particular writer means by this particular term on this particular occasion. Students have asked, in one way or another, how can it ever be justifiable to have a research design based on a theory of what you will find? Surely this is making a self-fulfilling prophecy. My answer to this is that theory is always present. You can't get away from it. Better perhaps that it is scientific theory than unscientific theory. To summarise then, here are the 12 points you need to fix in your mind. Number 1, theory has a special meaning in science. 2, a theory is different from a law. 3, theories are made of constructs. 4, strong theories can provide prediction, weak theories can only provide explanation. 5, theories should be expressed in precise, preferably mathematical language. 6, physical scientists study things. Social scientists study concepts. 7, concepts can be qualitative or quantitative. 8, models are possible ways things might relate to each other. 9, measures can differ in various ways. 10, research can be inductive or deductive. 11, research progresses from induction to deduction. And number 12, the paradigms researchers work within shape the research they carry out. I'm Dr. Peter Marshall, author of Research Methods, and I hope you found this helpful and that you'll join me for the next module in this series, which will focus on formulating hypotheses. Full information on this and all my other books and publications can be found on my website, drpetermarshall.com. You can also access my many articles and advice designed to help you in your career by following me on LinkedIn by using the link LinkedIn/in/Dr. Peter Marshall, and by following me on Facebook.com/drpeter.marshall.35.